Good morning, everybody. Today I'm going to explain you the remaining concepts after my videos. Means I did some electricity videos, and this is the next topic. And till Ohm's law and all I said. And anyhow, we know very well. Resistance means actually it is the obstruction offered to the flow of electrons by the conductor. Okay. So you can say electrons or otherwise electricity. Anything is fine. Okay. See, it means that when the electrons are moving in a conductor, the atoms of the conductor will oppose the flow of electrons. Okay, simply to say, for example, means that anyhow the topic is actually done. So simply to make you understand, I am writing. For example, by using a battery, the electrons are moving. Okay, so if when the electrons are moving, for example, electrons are coming like this. Okay, so now in the middle, for example, some atoms will be there. See, atoms means anyhow protons will be there and all. So this electron will collide it. Okay, and what will happen, this electron will go and collide it. For example, say this electron is coming and colliding it, for example, right? So as soon as it collides, what will happen, it changes its direction. For example, okay, it will come to here, and again here one more atom will be there. So again it will collide to it, and again it will go in this direction, for example. So like, so in that way what will happen, the electrons will be moving forward continuously, and again here it will collide to another electron, for example. So thereby what will happen, these electrons will be moving continuously, for example, like this. Okay, so in that way, so means electron which is coming from here, it is colliding and moving continuously in a single direction, means in a particular direction. Okay, so from means we generally say that see, current will move from plus to minus. Okay, positive electrode to negative electrode, but electrons will move from negative to positive. So in that way, for example, that side electron negative is there, for example, this side some negative is connected, and in that way, so generally current direction will take in the opposite direction, actually, like I will take like this. So here the obstruction is offered by the atoms present in the conductor, so that is called as resistance. Okay, resistance is anyhow simply you have to remember opposition or obstruction. The opposition means obstruction. Okay, means the atoms in the conductor oppose the flow of electrons. Okay, this is called as resistance. Okay, so the property of the material by which the material opposes the flow of electrons in a conductor is called as resistance. Done. Now what is actually our topic is not resistance, the factors on which resistance is. So if anybody want to stop it and see it, you can see, but I don't want this to be explained. Actually our main topic is this. Okay, you can take a screenshot and all. Okay, now we'll go to the next. Now see here, okay, see here, now you can see the total board, so that you can take screenshot also and all, you can note down all the points. And one more thing, before starting actual our topic, I want to say generally in physics these type of questions will be asked. If you see any question paper, direct question will be there. For example, in electricity topic, what will be direct question? Simple, what is potential difference, what is current, etc. Okay, generally such in electricity, generally direct questions they don't ask. Mostly they will ask like this, mostly numericals actually in electricity, and numerical connected with diagram like that, or otherwise diagram only separate. Okay, and application means the regarding heating effect of electricity like that, and the on electric bill means how we will get a monthly electricity bill. So that is like applications and all. Even heating okay, heating effects of electricity also you will get nichromware and all. That is nothing but application means based on some phenomena what we apply in the real life, that is called as application. Okay, okay, so that's what will come under applications, right? Why we will use nichrome wire and all. Okay, like that in heating elements like electric stove, etc. Now that's coming to the next direct question is what you call, what is current, etc. Reasoning question, why nichrome wire is used as a heating element like that. Why tungsten is used, tungsten is used as a filament in the wire. Okay, numericals anyhow, when resistors are connected in series and parallel. Okay, or otherwise by giving, for example, this formula is there, R is equal to rho L by. On this formula they may give some length, and they may give some resistivity value, rho value and A value, and they will ask R value. Okay, like that means resistance value. So numericals, diagram based numericals means when resistors are connected in series and parallel. Okay, how we are going to draw the diagram and all, series arrangement, parallel arrangement, like that. So in that way some problems will be the diagram based. Anyhow, I said about application. So these generally these 5 types of questions will be there. Okay, so any question paper, generally these 5 types of questions will be there in physics. That is the reason I said you. Okay, just I am rubbing. Okay, see, the question paper contains number of questions, okay, done, but all these questions will fall in physics in these 5 categories only. So this you have to remember. Okay, sometimes they may what you call mingle two parts, means I wrote numerical and diagram separately. Sometimes they may mingle, means they may give one question only, diagram based numerical. Okay, so in that way also possible. Okay, now we'll go to the next. Okay, and also diagram based numerical also is possible. Okay, now what we'll do, this one, factors on which resistance depends. See, what I am doing is I will just draw with red pen so that you can able to see it. For example, what I will do now, this is wire number 1, for example, this is wire number 1, first one is wire number 1, for example. So what I am doing in the wire number 1, for what I am doing, let us take symbols actually. For example, wire number means this part what I am writing with red pen is for your conceptual understanding. Exactly, okay, current won't become half like that. See, for example, this wire is wire number 1. So for example, it is made up of copper. Okay, done. Sorry, it is made up of, sorry, nichrome. Okay, nichrome wire. Okay, so what I am saying is, so this first wire is made up of nichrome, and if I take double the length, means here we bent it. In the activity of CBSE textbook, they showed the length twice by bending. For example, now without bending also we can take like this. For example, you are taking like double length you are taking, for example. Now what I am saying, instead nichrome wire material is done, length L you take, area A you take. Now let the current be I. Now for this wire again it is nichrome wire only, but this is second nichrome wire only, length is double, area is same, area no change, but current will become half. For example, means let you take, why? Because why I am writing let means, for example, let us if the length is double, let us consider the current will generally decrease, may not be exactly half, but we can say by decreased, we can say by doing by half, for example. Okay, you can do 1/3 also, 1/4 also, something like that. Now what is happening now, whenever the length is increasing, what is happening, the current is becoming current is reducing actually. So it means that the resistance increased. So by these understanding the first two, means compare the second one with first one. Okay, remaining all are same except length na. For example, nichrome wire is only there. Okay, and area of cross section is only there. But because of the change in the length, the current has become half, right? So it means that when length increases, resistance increases, and thereby the opposition to the flow of electrons, what will happen, opposition to the flow of electrons increases. Okay, so that point you can mention here. So R is, we have to read it as R is directly proportional to the length L. Now next one, third case, what I will do, this is first one, second one. Now third case, what I will do, I will take compared to, means you have to compare with first case. So always, so like that. See, now first case, how the wire is there, in that way only, means length is same, but area of cross section we are taking a little thicker one. Okay, but length is same, so L you write same, but area is twice you take. So current, let us consider current is 2I, means current increases. So by this we can say that, and this is also nichrome wire, by this we can say that material is same, length is same, but because of change in area, what happened, current increase in area, the current also increased. So it means that resistance will decrease when area is increased. So inversely proportional symbol you are use. R is proportional to 1 by A means whenever you write the whatever the left side quantity is there, that is called as subject generally. So the left side quantity, and after proportional, if anything is there in the down, means denominator, then they will be what you call opposite, in the sense, for example, A is when you are increasing, what will happen, for when A increases, resistance will decrease, that is the meaning, opposite. So that is the meaning. So this is called as inverse proportion. Anyhow, the students who know maths, direct and indirect proportion, or indirect variation, like that they will say na. So in that concept they will get, actually it has come in the 8th class maths actually. So that is, now by combining 1 and 2, so you can write here, by combine 1 and 2, for example, combine 1 and 2. So you can say either it is equation 1 or 1, Actually it is not equation, but generally we can take as something like 1 and 2, combine 1 and 2. Now R proportional to L by A you will get. Why? Because L is in the numerator, right, in the numerator, and A is in the denominator, right? Now in physics what we do generally, whenever we remove proportional symbol, we write equal to and write some constant. Here the constant is the nature of the material. Okay, so that also I'll say how. For example, compared to first, what you do, take the same length, same area of cross section, but material you take copper. For example, now you are taking copper symbol anyhow, you know, Cu. Okay, now the current will be anyhow, nichrome will offer more resistance, so current will be here more. For example, say 3 times or 2 times or something, like you can say it should increase. Okay, so anyway you can increase by 2 times or 3 times or something like that, you can keep any number, let, for example. Now what is happening, based on the material is also the current is changing. Okay, so that is nothing but rho. Rho is nothing but, so you have to pronounce it as rho only, but RH shows spelling, and this is the Greek symbol given. Okay, so that Greek symbol is RH rho. Okay, now so this rho is nothing but resistivity, and it is also the other name of resistivity is specific resistance. Okay, and it is nothing but the nature of the material, means compared to the first nichrome wire and copper wire, we are changing only material, remaining length and area is same. Okay, so because of change in material, as the current increases, it means that copper has less resistance than the nichrome wire. Okay, so that you have to remember. Now coming to the next, what is the if anybody asks what is resistivity definition, so sentence form I wrote. Okay, but mathematically what you do, change the subject, means what you have to do, you have to cross multiply this A this side and L this side. Now the formula you will get is like this, R is equal to rho, as rho is equal to RA by L, you will get. Actual formula in terms of R is this one. So this only by cross multiplication and all you will get this. Okay, why I wrote like this, because we want rho definition, resistivity definition, not R definition. So now keep, if L is 1 meter and area is 1 meter square, then if you substitute that, you will get R is equal, rho is equal to R, exactly. So it means the resistivity of a material, means of a particular material. For example, you take copper or nichrome wire, anything. So that, for example, you are taking nichrome wire. Okay, so the resistivity of the nichrome wire means it is, okay, the resistivity of that material means it is the resistance of the wire made up of that material of unit length. Unit length means what? 1 meter, and unit area of cross section. Generally unit length means, sometimes some people will argue, okay, what sir, it might be 1 centimeter also, something like that. Okay, generally we will take international system, that is SA system. Okay, so SI system will take, and let us call write in SI units only, meter and meter square, done. So in that way we can make it. So in brackets in the definition you can do that. Okay, now coming to the next, acha, what about the units? Yes, the units based on the formula you write SI unit. Generally in exams SI unit will be asked. They don't ask generally CGS system, FPS system, many systems will be there na, some 6th class students will be getting. Okay, so what we do is, according to this formula, according to means, again I am writing formula because actually in exam you no need to write the formula again, but for your understanding I am writing. See here, rho is equal to this. Okay, now see rho means what I am saying, this will become, okay, here, okay, here we will do like this, R unit is ohm, and A unit is meter square, and L unit is meter, right? Okay, I think it is marker is a little lighter, so I am making it thicker, right? Now what I am saying is, if you cancel 1 meter and in the denominator, and in the numerator meter square, means it means that meter into meter, 2 are there, so 1 you can cancel. So it means that what is left, rho, ohm into meter. So ohm meter is a unit. Okay, so the SI unit is, so what you have to write, the answer is, SI unit of this is ohm meter. See, in between, actually in between units you should not use any space actually, and also you should not use hyphen mark, comma, etc. Nothing you should use, full stop, etc. No punctuation marks, no space. Okay, so ohm meter, that's it, and dot also should not keep. Okay, so this is the, actually in 11th class you will get a rule to write the units. Okay, so the based on that I wrote. Now some people may say, sir, what if you use, okay, instead of symbol home we can write home meter also. Okay, home meter is also fine. Okay, OHM home and meter. Okay, that also fine, you can write that well. So OHM home, OHM home, meter, METRE. Okay, done. So that is also fine, but generally most prefer, people will prefer to write in the symbol form, short notation. Okay, right. Now we will do the next topic. So the next topic will be on the combination of resistors.